Hi guys, welcome to my channel. Today let's solve it as a lead code question. The description of the question is as follows: that we were given an infinite xy plane. So I'll just write some note points. The plane that's given to us is an infinite xy plane, and this is the first point given. The robot is starting at position 0 0. This is the second point that's given to us. The robot can receive a sequence of commands. So the commands that robot will receive will contain either -1, which means that a robot should be turning right if the instruction or command is -2, then we are specifying the robot to turn left, and if it is any positive value, then we are specifying it to move that units of the distance. So this is how or this is exact description that's given to us. And also, to make our problem slight complex, we are also given an obstacles vector. Contains the obstacles that are present in the vector at the given x and y coordinates. So this is the entire description that's given to us. Now if robot runs into an obstacle, then obviously it wouldn't be able to proceed further, so it would be stopping at the previous position only, and we need to return the maximum Euclidean distance. So Euclidean distance is well known, I guess. It would be square root of x2 minus x1 whole square plus y2 minus y1 whole square. That's what we define as an Euclidean distance. But given in the question that we do not need to consider the root. So if we do not need to consider the root, and also we need to specify from the origin, so we need to return maximum value of x square plus y square after every iteration. So for having this done, first thing what I'll do is, I'm given an obstacles in form of a vector, but that would make my searching more difficult. So I'll just add it in my set. I'll just call it set, and for every obstacle that's present in obstacles vector, ideally I would be adding that or inserting them into the set obstacle 0 obstacle 1. So this is how it's working, where I'm just specifying or I'm adding everything into set so that I could be checking that later at very easy rate to check if a particular xy coordinate is present within the obstacle or not. So here I'll just call it helper function, which helps me to check if there's an obstacle or not. If obstacle is present, then it will give me the number of units that need to be traveled so that there won't be any obstacle. If obstacle is not present, then it will give me complete units. So I'll just call int x, int y, int dir. So what the dir specifies is, or I'll just call k first, and next followed by dir. K is 1 to 9 when we were need to move the robot but not change the direction. And here I'll just call set of pair of int and it's to be st. So this is how it's working. So here what I'll do is, I'll just call dx to be 0. What dx and dy will be storing is the units or the number of units my x and y coordinates should be changing. And if my dir is equals to 0, I'm just specifying that if my dir is equals to 0, in the case that I am in the north direction, then my dy should be equal to 1 or plus or equal to 1. So if you just think of a Cartesian plane, two-dimensional Cartesian plane, then in a north direction, you are currently at an origin, then north direction is positive y-axis. So whenever you need to move some k units or n units towards the north direction, then you need to obviously change dy value. So ideally earlier my y is 0, now y added to dy will give me the fruitful result. So dy should be incremented by 1. Or else if my dir is equals to 1, so I'll just also specify here assumptions. dir to be 0 is considered to be not, dir to be considered 1 considered to be east, dir 2 is considered to be south, dir 3 to be considered to be west. So this is how it works. If dir is equals to 1, then dx would be incremented by 1. Else if dir is equals to 2, then my dy would be decremented by 1. Else if dir is equals to 3, my dx would be decremented by 1. So here I'll just check while k, and I'll just subtract k minus minus. Also I'll just call a start k to just check if obstacle came in between or not. If obstacle came in between, then ideally, or instead of calling this start k, no, I'll just call it start k only, or I'll just call number is equals to 0 while number is 1, number is less than or equal to k. So I'll just call it number plus plus. But instead of calling this number, I'll just make it more simple. I'll just call start k to be k, and I'll just check while my number of steps or while k. So I need to so what this while k will be doing is, ideally boolean value false is equivalent to 0 in decimal value, right? So it will be just checking while my k is not equals to 0. What it would be doing is, it would be checking st dot find x plus dx, y plus dy. If my st dot find is equals to, or I'll just specify that I have not found any obstacle, or sorry, I found an obstacle in between. In that case, earlier I'm having start k number of steps, and assume that I already so initially my k would be 9, and for finding the obstacle assume that I am at k equal to 6. In this case, how many steps have been traveled? 9 minus 6, 3 steps have been traveled. So but k is already changing, that's why I use start k. So I'll just call return start k minus k. And now after this, I already found out the direction, so x would be incremented by dx, y would be incremented by dy, and here I'll simply return start k. So this is how my helper function works. And after helper function, I need to have my x coordinate, which is initially 0 because my robot is at origin, y coordinate also 0 because my robot is at origin, and initial direction to be 0 because my current facing is towards north. So that's how it works. So now everything is done, so I need to follow the command. So I'll just call for auto command in commands, and I'll just specify if first of all, if my command is equals to -1, in that case I need to make robot turn towards 90 degrees towards right. So if I need to make my robot turn 90 degrees towards right, then north, if I am currently facing towards north and I turn 90 degrees towards right, then my current facing would be east. And similarly, standing in east, if I turn 90 degrees, then my facing would be south. So how I am getting north, east, south, west. So for getting east from north, what we are doing is, we are just simply specifying that direction would be direction plus 1% 4. That's fine. Why percent 4? Because if I'm in the west direction, then ideally turning 90 degrees towards right should give me n, but here it would give us 4. But 4 won't make any sense because those are reminders and 0 to 3 values are valid. So in that case, I'll just call dir equal to dir plus 1%. And if my command currently is equals to -2, in that case I need to turn left by 90 degrees. In that case I'll just specify dir would be dir minus 1% 4. That works fine for east because currently I'm at east direction. I need to turn left by 90 degrees, that would be north. For south it would be east, for west it would be south, but for north it should be west. So for happening or for having north to become west, what I'll specify is here negative value should not be present ideally. Here negative value should not be present ideally. So in this case, as negative value should not be present, so I'll just add 4 to this, so that ideally 4 and 1, 4 minus 1. So what I'm just trying to say here is, if I added 4, then 4% 4 anyhow is 0, so that won't cost anything extra to us. But in that case, for north we would end up with a fruitful answer. So if I added 4, then ideally it would be 4 minus 1, so I'm just calling it direction plus 3% 4. That's how it works. And if it's else, then I'll just call it count, and after calling count I'll just call helper to be x, y. My current k would be command now, because that's, if it's not -2 -1, then my command would be k value only. And my direction would be the current direction that I am standing into, and my set would be the set. So here as well I'll just check if my direction is equals to 0, then my x would be equal to count, sorry, y would be plus equals to count. It's exactly the same thing which we done earlier, but instead of adding dx value dy value, we already got a count from above function, so I'm just using that count. If dir is equals to 1, then that would be x plus equals to count. If dir is equals to 2, then that would be y minus equals to count. Else it would be again x minus equals to count. So that's how it should work. And ideally I just lost my internet connection, so just a second, I'll just try running it. No, after having this done, I also need to return answer as my max Euclidean distance, right? So answer should be max of answer x into x plus y into y. So I'll just need to return answer. Just a second, I'll just try reconnecting through my mobile Wi-Fi. Sorry, through my mobile hotspot. I'll just connect it and I'll try running this out. Else I need to pass over here. Just a second. So I'm just running this out. Oh, I'm getting network error. I'm not sure why that's happening, because I just connected my Wi-Fi. So I'll just try submitting this out. Exactly, everything is working as expected. So to fairly reduce complexity, what I'll specify my C++ compiler is not to import any libraries from C. That would be helpful, or that would be helping to take input or give output to the terminal, because in this case I'm just simply returning out the answer and I'm not taking input or giving output anything. So I'll just try submitting this out. Currently runtime is 66 milliseconds, so it would be reduced fairly, and we made it 52. So feel free to add anything in the comment section if you think anything is unclear. Thanks a lot.